Okay, I want to go over a concept because there is a um, special type of logarithm. But before I do, I want to just kind of do a little experiment here with compound interest. And if I were to, here's the formula. A equals P times 1 plus R over N to the NT power. P is the principal. That's how much you invest in an account. R is the interest rate. N is the number of times, this is for compound interest, number of times you're going to compound in a year. And T is the number of years. Now, what we're doing here is, let's say, I'm going to make a table here. And of N, the number of compounding periods in a year, and just figure for, let's just say, now, if you could do this, this is R, if you get 100%, and then how much money would that give you? If R is 100%, and let's just say we're going to do $1, that the principal, that P is just $1. And that just gives us, for a unit there. If I were just to figure that out once, P is 1, so I'm not going to write that, but 1 plus, and 100% is 1, divided by 1 to the first power. So that's 2 to the first power. So if I just had one compounding period for my $1 that I'm putting in the bank at 100% interest, at the end of the year, I'm going to have $2. Well, let's suppose, let's use the formula. Let's suppose I want to do that for every month. Every month they're going to calculate the interest. So I will take 1 plus, now my rate is 100%, which is 1. So 1 plus 1/12 to the power of, and this is just for 1 year, so T is always going to be 1. So I'll just do 1 plus 1/12 to the power of 12. 1 plus 1/12 to the 12th power. And I'm getting 2.613. I'm going to go to the nearest tenth of a cent. So $2.61. So if I were to compound every month, I would get 60 more cents. And relative to $2, that's fairly significant. Let's say I did it every week. Let's say I compound 52 times. Let me just put that entry in. I can change those 12s to 52s. So in that case, I have my dollar. I'm the 100% divided into 52 parts and then raised to the 52nd power. Whoops, let's do the interest there. 2.693. Okay, I get a little more. I get 8 cents more. But notice it's not as much as the 60. But even though we got a lot more interest periods there. Well, we've done weekly. Let's do daily. What happens if I do 365 times? This isn't 20. This would be for 2021. It's not a leap year. So I'm going to actually recalculate that. 1 plus 1 divided by 365. That's 1 over 365. That's the interest rate we get each day. And then we're doing that 365 times in a year. Okay, boy, it doesn't go up much. 2.715 if I round. If I do it daily. Well, let's say I do it every minute. So 365 days. No, let's do every hour. Times 24 hours. That's 8,760 minutes. So I'm going to do 1 plus 1 over 8,760. I'm taking that 100% and split it into 8,760 times and raising that to the 8,760th power. Okay. 1 plus 1 divided by 8,760. And then raise that to the 8,760th power, 2.718. Okay, this is daily. This is, if we're just doing interest every hour, we're going to figure out interest. I'll write down the 8,760, and I get 2.718. Boy, there's very little difference daily and hourly. Let's just do one more. Every second of every day, of every hour, every second of every minute of every day, of every hour. Okay, you know what I'm trying to say. How many seconds are in a year? Let's take 365 days times 24 hours times 60 minutes times, well, I'm on minutes now, times 60 seconds. Okay. So I am going to take 1 plus the 100%. I'm dividing it by, what is that? 31,536,000 and raising it to that power. 31,536,000. Oh, look at that. 2.718 again. I'm not even put that number there. But if I were to figure out interest, see how it went up pretty quickly. And then went up just a little bit, but then at very little difference. So if I were to do it infinite times, the number I would actually get is E. And we are really approaching E here. And I want to show you where E is. We have an E to the X power here. So if I hit second and then it says E to the power of 1, there's a number designated. And look how close that is to what we have. To 5 decimal places, it comes up to our second. So if we were to just do it infinitely, we are talking about E, and this is how far I usually remember it, is approximately 2.718. And that number is like pi. You know, pi is approximately 3.14. It is irrational, but it comes up, and it's a number in nature that comes up, and it has uses. Okay? And where it comes up into play here is in these are natural logs. Okay, natural logarithms. That's what the LN. And all they mean is log base E. That is what LN means. But let me write that in a little clearer. That would require starting over. Okay? So log base E this is the notation for that. Okay? It's special enough to have its own notation. So if I were going to rewrite this is log base E. So my base would be E. My power would be 5.165. And then if I take E to the 5.165, I should get something very close to E to the power of 5.165. I should get something very close to 175. In fact, I'm going to actually check that. E to the 5.165 power, 175.03. So that is approximately that. And then if I'm going to write in natural logarithmic form, I'm going to write natural log, this is log base e, of 1096.633 equals 7, is approximately 7. We're rounding. And if I just needed to find the natural log of 2/3, I would just hit this button. You've got an LN button right there. Right there. Natural log of 2/3 is equal to negative 0.405. I'm going to say approximately negative 0.405. Okay, let's talk assignments here. These questions are all relatively short, so I'm going to have you practice a decent amount of them. On pages 378 and 379, I want you to do 7 through 24 and 49 through 60. All right, you guys take care. Bye for now.